So good evening everyone. I'm Nicolas Bourriez. Currently I'm a research engineer at the Computational Biology and Bioinformatics lab at Institut de Biologie de l'École Normale Supérieure. And I'm looking for a CIFRE thesis, so please reach out. So yeah, I'm going to talk about my path as my previous colleagues did, of course. And so, disclaimer, today you're going to hear from former businessman who just reached Central Master afterwards. Because yes, I did the class prépa before, so Saint-Jean-de-Douai for 2 years, and then I entered M Lyon Business School. And during this path, I just did like a specials program in partnership with Epitech. Then I followed like the normal path of a guy coming out of a business school, which is some internships in some big companies. So I chose Capgemini because I was very interested also back at the time already at AI. And so I was a consultant data scientist intern at Capgemini. And then I did another internship at AXA Group Operation, but in AI for cyber defense, which was very interesting also. And then I reached out to Central, and magically they opened the door to a business guy. And so that was the best decision of my life, basically, because afterwards I did a research internship at Ibens. I just loved it, and then I stayed as an engineer and looking for a thesis. So a big U-turn, as you may say. And indeed, for U-turn, why basically MSc AI? I just, sorry for the business guys here, but I just didn't want to go into consulting firm or finance or work like a 9-to-5 job and do some slides basically. And so, yeah, I was already kind of interested a lot into code, math, intellectual challenges. And so I just wanted to make a change in my career. And so that was basically what I was looking for. I was looking for theoretical and mathematical excellence, learn, of course, deep learning, and that's the hype today, practical hands-on with a coding expertise. Also understand what is really under the hood and explore a lot of other related topics to AI. I think we had like a good team of teachers here that taught us those related things. So that was perfect for me after like entering this MSc. I thought like the path was going to be easy. And during this MSc AI, of course, we all had the research. So I'm not going to talk about all this. It's just to illustrate. But the research project already gave me a sense of, okay, I need to enter the research field because I just love it. It was with the professor Adam Abdin, I think he's not here, and one of my colleagues, Adrien. And so we were facing one big problem. We're still facing this big problem, is that we got an exploding, like an exponential growing pollution of the space, so orbital pollution. And we needed to find a way, we proposed a way in order to try to avoid collisions. So spacecrafts need to avoid collisions in an automated way. And so that's why we worked on a deep reinforcement learning approach here. So we basically needed to simulate the collisions, work on an iterative algorithm, deep Q network here. And we found an interesting approach, which is a partially observable Markov decision process. Basically, we know that in space, we don't know a lot of things, and we are looking at an environment that is stochastic. So it's partially observable, and that changes a lot of things to our problem. And so, yeah, it turns out that we made a paper out of this, so that's great. Afterwards, I entered ENS for an internship. And it completely changed topic, because the topic here is a link between biology and AI. In this lab, they are mostly focused on phenomics, so the analysis of basically microscopy images. And here, as we can see, most images are cell painting images. So the topic of my internship was kind of ambitious: build a foundation model to treat any kind of microscopy image. So to do that in 6 months is kind of hard. But the main problem that we faced was that, of course, in biology, we don't have the same type of images that you have, like RGB images, natural RGB images. And basically you have different type of images, of microscopy images, and different types of channels that are in these images. And we wanted to basically build a model that can take any kind of number of channel of microscopy image and be intelligent over this image. So we built a simple transformer that can just do this task quite good. And so, as you can see on the right, what is interesting is that using this model that learn on different, like very heterogeneous data set of microscopy images, we can predict basically here the channel of B-tubulin, which is a kind of organelle that you can see in cells, using only like the actin channel and the DAPI channel. The DAPI channel is just showing the nucleus here. And so, as you can see, compared to the ground truth, it's kind of good. So also we had good results. We published in another good conference. So that started well for a business guy. Then, in terms of other kind of results, we showed that this model has also a very good intermodal analysis capacity. So basically, since we compute attention between channels and inside the channel, we had just better results at this point. And so after like just after this, at the very beginning of my research engineer career, basically, I also worked. I helped gave a hand to a colleague on another paper, and I managed to see some previous professors. So Maria and Stergios at Athens for the ISBIC conference. So that was quite nice to see them here and to discover Athens during this conference with them. Then my current projects are quite different. So as an engineer, I worked on something that is more simple in terms of research. We are focusing on malaria detection, but as you may know, malaria is just so paludisme in French. And you can detect very easily if a cell is infected. Just looking at the cell using a microscope, you see if you got basically a parasite inside your cell. But you got some difficult cases at the very beginning of the infection. Some guys don't have any parasite, but we know already that the disease is here. And so that's why malaria is continuously spreading, because they are not just well recognized using the microscope. So here we're trying to build a model using AI so that you can take just your smartphone, put your smartphone in the lens of the microscope and tell that this guy is indeed infected or not, even though you don't have any parasite in it. And then I'm currently working on my thesis project. So we're trying a bit as Alexandre is doing for materials. Here is more looking at the drug discovery side. So we want to build a multimodal model that can assess using different kinds of data, because in biology you have a lot of different kinds of data. You have, of course, the images, but you have RNA-seq, a lot of different omics in terms of also different spatiality. And so we want to gather everything inside the same latent space and then explore this very interesting latent space in order to retrieve new potential compounds that could help cure some kind of targeted disease. It's still a work in progress, so I hope that I'm going to manage to find that. And so, yeah, a last word on my side. Thank you, Central Supélec. I think this pass wouldn't be possible without you. And yeah, RERB commute was worth it, definitely. Thank you very much.